Software testing is a crucial part of the software development lifecycle, like SDLC, because it ensures the quality, security, and reliability of software products. Below are the key reasons why software testing is important. The first reason is software testing ensures software quality. Software testing identifies and fixes bugs before software reaches users. It improves performance and efficiency of the application. It helps deliver a product that meets user expectations. The second reason is it enhances security. Software testing detects vulnerabilities and security flaws in the software. It prevents data breaches, cyber attacks, and unauthorized access. It ensures compliances and security standards. Saves time and cost. Finding and fixing bugs early in development is cheaper than post-release fixes. Reduces maintenance cost by preventing recurring issues. Helps avoid financial losses due to software failure. Improves user experience. Ensures the application functions smoothly and efficiently. Provides a bugs-free experience, increasing user satisfaction. Helps in retaining user by offering a stable product. Ensures compatibility and performance. Test software across different devices, browsers, and operating systems. Ensures high performance under different loads and stress conditions. Helps in optimizing software for scalability and reliability. Compliance with industry standards. Ensures adherence to industry-specific regulations. Maintains the credibility and reputation of the organization. Avoids legal and financial penalties due to non-compliance. Facilitate continuous improvement. Provides insights to potential improvement for future releases. Helps team develop better coding practices by identifying weak areas. Encourages iterative testing to enhance software evolution. Software testing is essential for delivering high quality, secure, and reliable software. It helps businesses reduce risk, improve customer satisfaction, and maintain competitive advantage in the market. Skipping testing can lead to software failures, financial losses, and reputational damage, making it a non-negotiable step in software development. White box testing. It is also called clear box, glass box, or structural testing. White box testing is a software testing technique where the internal structure, code, and logic of the software are tested. Testers have full access to the source code, and test cases are designed based on the software's internal implementation. Key features of the white box testing. Access to code. Testers analyze and test internal working of the application. Logic-based testing focuses on the flow of code, decision points, loops, and conditions. Performed by developers and testers since it requires programming knowledge. It is usually done by developers or specialized testers. Objectives of white box testing. Verify code correctness and logic flow. Identify security vulnerabilities and hidden errors. Ensure optimized performance of the software. Improve code maintainability by detecting unused code. Common techniques in white box testing. Statement coverage. It ensures every line of code is executed at least once. Branch coverage. Test all possible branches of decision points. Path coverage. Ensures all possible execution paths are tested. Control flow testing. Verifies loops, conditions, and logical paths. Mutation testing. modifies code slightly to check if test cases detect errors. Advantages of white box testing. Thorough testing covers all possible scenarios and hidden errors. Security assurance identifies securities risks like vulnerabilities in the code. Optimized code help in improving code efficiency and maintainability. Bug detection finds critical issues that black box testing might miss. Disadvantages of white box testing. It's time consuming. It requires detailed knowledge of code and logic. It's expensive. It requires highly skilled testers and extensive resources. It is not user centric. It focuses on code rather than user experience. Testing a login system with an authentication algorithm is a good example of white box testing. A white box approach would involve analyzing the source code to check for security vulnerabilities. A tester might trace execution paths to ensure that all conditions behave as expected. When to use white box testing? During unit testing to verify small components of the software, to perform security testing and detect vulnerabilities, for performance optimization by reviewing and improving the code. White box testing is a powerful technique that ensures software quality, reliability, security, and efficiency by analyzing internal code structures. Although it requires technical expertise and time, it is an essential method for delivering high quality software. Black box testing. It is also called behavioral testing or functional testing. Black box testing is a software testing technique that focuses on verifying the functionality of the application without knowing its internal code structure or logic. It tests the system from user's perspective, ensuring that inputs produce expected outputs. Key features of black box testing. No access to source code. Testers do not need programming knowledge. Focus on functional behavior. It validates how the software responds to different inputs. It is performed by QA testers and end users, conducted by independent testers, quality assurance teams, or even end users. Objectives of black box testing. It ensures the software meets functional requirements. It identifies user experience, issue, and usability flaws. It validates system responses to different inputs and edge cases. Tests the software's performance, security, and reliability. Common techniques in black box testing. First is equivalence partitioning. Divides input data into valid and invalid groups to minimize test cases while ensuring proper coverage. Second technique is boundary value analysis. It focuses on testing at input limits. Third is decision table testing. Uses rule-based scenarios to validate system responses under different conditions. Fourth is state transition testing. Test different states of system based on inputs and conditions. The fifth is error guessing. Uses tester experience to predict potential failure points in the system. Advantages of black box testing. No coding knowledge required. It can be performed by testers without programming skills. User-centric approach. Mimics real-world user interactions and ensures a smooth experience. It is effective for large systems. It can be applied to complex applications without understanding their code. It is independent testing. Developers and testers can work separately to ensure unbiased validation. Disadvantages of black box testing. Limited internal insight. Cannot test code structure, logic flow, or performance bottlenecks. Inefficient for debugging. If a bug is found, developers may need extra effort to pinpoint its cause. It requires more test cases. Since internal logic isn't known, more tests are needed to ensure full coverage. Example: testing an online banking system. A black box approach would involve testing login functionality with different user credentials, ensuring correct error messages for incorrect inputs, and verifying successful transactions without accessing the underlying code. A tester would input values, observe outputs, and compare them to expected behavior. When to use black box testing? During functional testing to ensure software works as expected. It can be used for user acceptance testing before release. And it can be used in security testing to check for vulnerabilities without internal access. Black box testing ensures that software meets user expectations by testing its functionality without looking at the code. While it is efficient and user focused, it lacks the depth of internal testing found in white box testing. There is a key difference between black box testing and white box testing. The black box testing is external testing and does not require coding knowledge, while white box testing is internal testing and requires programming knowledge. Both testing methods are essential in the software development lifecycle. Black box testing ensures software meets user expectations, while white box testing ensures code quality, security, and efficiency. A combination of both is ideal for thorough software testing. Future trends in white box and black box testing. The future of testing is AI driven, automated, and security focused, with DevOps, AI, and cloud integration becoming standard. Testers will shift from manual execution to AI assisted decision making, making software testing faster, smarter, and more effective. Thank you guys. See you in the next lecture.